Hello students, welcome to Isha Schools. Now we had done till rational numbers of this chapter till now. Now we will start with irrational numbers. We had done a lot about rational numbers like getting rational numbers between two numbers, maybe whole numbers or fractions. So we wrote 5, 6, 7 as per the requirement. So we did everything about rational numbers. So after rational numbers comes irrational numbers. Now what are irrational numbers? The whole topic is about irrational numbers. Now, Pythagoras was the first person to discover about irrational numbers. Alright. So, now Pythagoreans in Greece, they followed this great philosopher Pythagoras. All the Pythagoreans, they followed this great philosopher Pythagoras, who was the first to discover about irrational numbers. What are irrational numbers? The irrational numbers are those numbers, they are called like that. Why? Because they cannot be written in the ratio of integers. That is, they cannot be written in the form P by Q or A by B, where denominator is not equal to 0. Alright, so we could not write these numbers as in the ratio of two integers. Alright, so those numbers which could not be written as a ratio of two integers or in the form P by Q, A by B, where denominator either Q or B is not equal to 0. Otherwise, if it is equal to 0, it is not defined. Alright, so irrational numbers are those numbers which cannot be written in the form P by Q or A by B, where the denominators are not equal to 0. Alright, so those numbers are called irrational numbers and they can be represented on the number line. They are real numbers. Irrational numbers are real numbers. Alright, they can be represented on the number line. Alright, that is why they are called real numbers. So we'll come to that. Okay, so he was the first one to discover about the irrational numbers. For example, now you may ask, what are irrational numbers? Like root 2, root 3. Alright, they are numbers which are not terminating. Alright, and they are numbers which go on with the decimals after division. They are not terminating. You will not get remainder as 0. Alright, so they go on continuing like root 2, root 5, root 7, root 11. Alright, all prime numbers under the root. Alright, so all the prime numbers under the root are called irrational numbers. Alright, so coming to the next irrational numbers. As I have already told you, a number S is called irrational if it cannot be written in the form P by Q, where P and Q are integers. That means they cannot be written in the form of ratio of two integers, provided there is a condition where Q not equal to 0. Alright, Q not equal to 0. These are irrational numbers. For example, root 3, root 5, root 2, root 11 and so on. Alright. So these are irrational numbers. Now coming to what are real numbers. As discussed earlier, we have already discussed about it, but let me tell you again, because with this concept, we will be doing some of the problem sums in the exercise. All right, some reasoning sums, not problem sums, some reasoning sums, whether they are true or false. If true, why? If false, why? So such type of questions we'll be discussing. So before discussing that, let us again just go through what are real numbers. All the numbers existing in this real world are real numbers. Now, as I have told you, everything, every definition, every concept has an exception. Maybe one, maybe two or many, but definitely has an exception. So, what is the exception in this? The exception is all the numbers in this world are real numbers, except the imaginary number, the complex number I. Okay, so complex numbers are not real numbers. All right, because I, the complex number I has value root over -1, and negative numbers under the root are not defined, are not solvable. Okay, we will use I to solve them, which are not real, they are imaginary. Whatever answer you get using I is not exact. It is just imagined this may be the answer. All right, may be. All right, so except complex numbers, all the numbers in this real world are real numbers. You can tell me any number you want. Yes, natural numbers, whole numbers, correct? Whole numbers, integers, rational numbers, irrational numbers, all the numbers, negative, positive, both are real numbers. All right? So, this is the concept of real number, and every real number can be represented on a number line. Whether rational, irrational, integers, whole numbers, whatever. All the real numbers can be represented on a number line. Represented means we can make a point on the number line and tell that this is the number. All right. So, we can represent all the numbers, real numbers on the number line, except complex numbers. All right. So, these are the concept which we have read now about irrational numbers and real numbers. With this concept, we will move on to solve some examples, and of course, after the examples, we will come to the exercises. All right. Okay. Now, after this, let's get started with the examples. All right. Okay. Now, the first example. Now, I told you just now that we can locate all the real numbers on the number line. Now, till now, prior to this, we had located integers, whole numbers, all right, positive, negative, both integers, fractions, that is rational numbers, all on the number line. Now is the time to locate irrational numbers on the number line, because the chapter deals with this particular topic, deals with irrational numbers. And because I said it can be located on the number line, it is not I said, it is already said in the book, it is located in the number line. Okay, now let us see, let us locate it. All right. Now, locating the number line is construction, that is geometry. All right. Before I start off with the construction of such like maybe root 2, maybe root 3, root 5, all right, any irrational number on the number line, when we particularly with the geometry, all right, when we start a geometry work, construction specially on the page. All right, whether it is a number line or construction of anything, there are very simple and very important rules you should follow. You might think it's okay, it will be done, but that will reflect in your construction and you may have to lose marks. So why? Why should we give the scope of that? All right. So as I was the part of the board corrections and we were given certain rules to correct that particular sum on geometry, that is especially construction, there were a set of rules which we were given. All right. So I want to share those rules before we start with the geometry. First of all, a compass should have a short pencil and you should have a long pencil. There are children who adjust with that, but no. You in the board exam, you are given a specific time. You cannot take as much time as you want, isn't it? Yes, if it is a simple class or the work at the home, it's okay. All right. So a long pencil just for drawing the lines and a compass pencil, definitely a short one, so that it is easier to move about with the pencil using the compass. And ruler, definitely. While doing the construction, I will definitely show you how to hold the ruler. Of course, you are in class 9, so you might have known everything. But just a survey or a recapitulation of what I want to tell you. All right. So holding the ruler, and how can you do the construction accurately, perfectly and neatly? Neat work is always a first priority. The first priority in doing geometry sums. All right. Now, one more thing. If I have to draw a line segment, all right, a line segment, it is very essential that you put both the end points. A line segment has two end points. So those end points are very important so that your calculation, that is if it is of 6 centimeter, you join the two end points from 0 point to 6th point. That should be marked as a dot first and then you join the line. All right, that is what is accurate measurement. And one more thing, I have seen children doing sums using compass if you have to take a particular measurement, suppose 2 centimeter. All right, 2 centimeter. Now, I have seen children, they just put a ruler like this and use the compass to move up and down. All right, or they put it on the table and move the compass for 1 or 2 centimeters. To get, see, in that process, the compass might move a little. We are human beings, isn't it? After all, there may be mistakes. Even your hand can shake, whatever can happen. So, better to get for accurate measurements, please draw a 2 centimeter line in the side, at the side also, or in your rough column. It is your wish. All right. Better to draw a 2 centimeter line. After drawing the 2 centimeter line, use the compass. All right. Use the compass and have the accurate measurement putting on that line rather than putting on the ruler. Now, ruler is made up of plastic. All right. And your compass is made up of course, the steel metal. So, there are a lot of chances that the compass might move by 0.1 centimeter, and moving by 0.1, the entire calculation is gone. All right. So, to avoid such things, please draw a line at the side, whether according to the requirement. If 1, then draw 1, otherwise 2, 3, whatever is required. All right. So, always draw a line at the side and use the compass to draw the measurement from that line rather than using the ruler and measuring. All right. So, these are a few rules. If you follow, never ever will you go wrong in accuracy or the measurement of the line. Everything is measured while correcting. all right, including the angles, everything, all right. And while locating the number line, we need 90-degree angle. Please use a compass, not a protractor. All right, use a compass to draw 90-degree, and this locating on number line, only three things: pencil, compass, ruler. Of course, eraser if needed. All right. So let us start locating root 2 on the number line. All right. Now I will be telling you step by step how to start and end locating root 2, which point will be root 2 on that number line. All right. Now let us start. The first thing, we need to draw a straight line. All right, a straight line. All right. Now, I told you, whenever you draw a straight line, yes, we have, okay, we have a ruler. Please hold the ruler like this. All right. Now, always hold the ruler like this and draw the line from the top. Never hold the ruler and draw the line from the bottom. Is it clear? This is very important. If you hold the ruler and draw the line from the bottom, there are many chances that the line may not be straight. All right? So, coming back, you will hold the ruler and draw the line. The first thing. All right? The second step, locating a point on the number line. All right? Now, this is root 2. This is 1 centimeter. All right? This is 1 centimeter. I will write it this point as 2. The point which I have taken in the beginning is 1. All right? Now, again I have taken a point 1 centimeter, which is 0. So, I have taken 3 points. 0, 1, 2. Alright. Now, you may ask me, why did I take 1 centimeter distance? Why didn't I take 2 centimeter distance? Alright. Now, let me show you just a rough work how you get root 2 with a right angle triangle. Now, we are going to use Pythagoras theorem. That is why in the beginning I told you a little about Pythagoras. Alright, so we will use Pythagoras theorem. Now, just a rough work of right angle triangle. Now, this is a right angle triangle A, B, C. Alright, now I have taken 1 centimeter here and 1 centimeter here. According to Pythagoras theorem, AC square is equal to AB square plus BC square. Alright, so AC square is equal to 1 square 1, 1 square 1. AC square is equal to 2. AC is equal to root over 2. So, I get these as root 2. Now, this same thing I will show you how we have to construct on the number line. This is the concept behind drawing this number line. We will use this concept, the Pythagorean principle, the theorem which states that hypotenuse square is equal to base square plus side square. Alright. Now, if I take 1 and 1, then only I will get root 2. That is why I took 0 to 1, 1 and 1 to 2, 1. Alright, 1 centimeter. Now, I will draw, alright, 90 degree on 1. Alright. Now this 0 is C and 1 is B. Alright. 0 is C. I'll just write here for your reference. Alright. I'll circle it. And 1 is B. Alright. Just for reference. The C and B no need to write in the exam. Alright. So reference. The next step I will take now for my convenience so that I need not change, because this is 1 and 1. I took the radius as 1 centimeter in the compass. Alright. So it will be easier for me, isn't it? Yes. So I took a radius of 1 centimeter. Now, after taking the radius of 1 centimeter, I fixed the compass here and drew the semicircle. This is the next step. The first step is to draw the points on the number line. The next step, to draw 90 degree, I have taken 1. Why did I take 1? Because here the 90 is at 1. Alright, so this B is B over here. So 90 is 1. So at 1, I need to draw 90 degree. For that, I need to use a compass. I took 1 centimeter radius for my convenience, and from taking 1 as center, I drew a semicircle. Done? So semicircle is drawn. Now I want the angles. Let us see that. Now, the first angle taking 0 as center. Same radius. Please remember, children, same radius. Alright. The radius which you drew the semicircle with that same radius, but 0 as center, we will cut an arc. The first arc means it is 60 degree. Alright. Now, with this point as center, alright, at 60 degree at center, we will cut another arc. So, the first center is at 0, we have cut an arc. The second center at 60 degree, we have cut another arc. Now, 60 plus 60 is what? Yes, 120. This is 60, this is 120. Now, we all know 90 lies between 60 and 120, and lies not, it is exactly at the midpoint of 60 and 120. 120 plus 60 is 80, and 80 by 2 is 90. So, midpoint of these two arcs will fetch us 90 degree. Alright, let us see that. Now, the next step. Alright, now see, with 60 as center, one arc, with 120 as center, another arc. Okay, now where these two arcs meet, that point and 1, the point at 1, I will join. Alright, now I have joined. Joining is over. This line. Alright, this angle is 90 degree. Done? So, why we have to use 90? Now, you may ask me, why did we draw 90? If we don't draw 90, we cannot use this formula to get root 2, isn't it? We cannot have the Pythagoras theorem in our formula. Okay, so we have taken it as 90. You have to use 90. Alright. Now, from 1, see, I am telling you I took 1 centimeter radius for my convenience. That is the convenience. I need not cut 1 centimeter now. Alright. Now, usually, if you don't take 1 centimeter as radius, from 1.1, you need to cut 1 centimeter. Alright, so you will have to cut 1 centimeter because from 1 we need 1 centimeter. Now what is this 1 centimeter point? It is the A which we have taken in our example. Is it clear? Now this A, please don't write in the exam. This I am explaining only with the reference of the rough diagram. Alright, this A, B, C is just for you to understand. Alright, so this is the point 1 centimeter. I have taken radius 1 centimeter, so I need not cut separately. But if you have taken more than 1 or less than 1, you have to cut in this step from point 1 as the center, you need to cut a 1 centimeter arc. Alright, now I have taken 1 centimeter, I need not cut again. So I can use this time to finish off the next, isn't it? So I am saving the time now. So done. This point is 1 centimeter. So I have got BC1, this is 1 centimeter. I have got BA 1 centimeter. Done. Now, as per the Pythagoras theorem which I have showed you now, I have to get root 2, isn't it? Now, how do I get root 2? I join this point. Now, this is point A. Suppose this is point A. I join A to 0 point. Now, how is that done? This is the joining. Is it clear? Now, I have joined this. This is 1, this is 1. Definitely, this is root 2 centimeter. Okay? So, this is root 2. Now, the construction is not over yet. We haven't located it on the number line. Our question is, it is to locate on number line. We have just constructed. Till now, we have not located. Now, we know the value of root 2 is 1.414. It extends. It extends. Alright. Now, this we have to locate on number line. How do we locate it on the number line? Now, till now, we took the same radius 1 centimeter. Now, we need to change the radius in the compass. Now, the radius changes. The radius is the point 0 to A. Alright, this point from here to here is the new radius. Alright, with this new radius, we will take O as the center. And cut an arc to locate it on the number line. Now, what is that arc? How do we get that arc? This is the arc. Is it clear? So, what is the radius which you took for this arc? The radius is from point 0 to A. When you take this and draw the arc, this is the way it is drawn with the compass. So, this is the arc. This point is the point of root 2 on the number line. Now, when you construct, if you have doubt whether I have done it or not, root 2 is accurately located on number line or not. Now, I said 1.4. That means near 1.4 or a little, it will be on 1.4, definitely. Alright, because after 4 is 1, so roundabout it is 1.4. So, you can easily measure from 0 to here, it will definitely show 1.4. And if it shows 1.4, that means your construction is right. Absolutely right. Now, the only care you should take is, while drawing, you should see the 90-degree point and the point from where the arc is drawn, from where the semicircle is drawn. All that is very, very important. Alright. So, this is how we need to construct, locate root 2 on the number line. And let me tell you, please draw this rough work on the, maybe on the side or on the rough column, whatever, wherever you wish. But please do this, because this will help you to locate and follow the procedure. With the help of that, you can easily locate it on the number line. That is the help, the guide to locate on the number line. Because when the teacher corrects this sum, she will see that and half the job is done. Half the job is done and the rest is construction. All right. So that is very, very important. All right. And please now, this is root 2. Please don't forget to mark the units. Root 2, 1, 1, all these, and 90 degree. These are very, very important. All right. So root 2 is located in this manner. All right. Now let us come to the next example. All right. This is example 4, root 3 on the number line. All right. Now, before I start this, let me tell you, root 3 is just the extension of root 2. All right. Root 2. But after the extension, that is after we finish root 2, root 3, you have to turn your notebook or adjust in such a way that you get the base as per your convenience. All right. Now, while doing the sum, I'll tell you, doing the construction, I'll tell you how to do and keep the notebook for your proper convenience. All right. Now, let me start. The first thing, as I told you in root 2, the first thing is to draw a straight line. All right. Now, again a point. All right. Now, root 3 is an extension of root 2. So, we have, for drawing root 2, locating root 3 on the number line, we have to follow all the steps of root 2 first and then continue for the root 3. All right. So, this is 1. All right. The next step, this is 2. The next step, this is 0. So, we have located the numbers on the straight line. This is the first step which we have done. Now, after this, now root 2, as I told you, is 1 plus 1 square plus 1 square. Root over is root 2. So, 1 centimeter we need to take everywhere to get the value of root 2. All right. So, for my convenience, I have taken 1 centimeter as radius. All right. So, taking 1 centimeter as radius and 1 as center. All right. 1 as center, I have drawn a semicircle. Yes. 1 as center and the semicircle is drawn. Now, we are drawing 90 degree. All right. With that same radius, please don't change the radius. All right. So, with that same radius, now shifting the center from 1 to 0 because we want to find the angle. So, shifting 1 to 0, from 0, we cut an arc. All right. The first arc is 60 degree. Now taking 60 degree as the center, we will cut another arc. All right. From 60, same radius. So 60 plus 60, 120. The second arc is 120 degree. All right. Okay. So you have mastered now because we are repeating the steps. So you must have mastered by now, isn't it? Great. Now the second arc is this. Now 90 degree lies between 60 and 120. Midpoint. So midpoint means 60 plus 120, that is 180 by 2 is 90 degree. All right. So the 90 degree will be exactly at the center of 60 and 120. All right. Now, with 60 degree arc as the center, I cut one arc and same radius. Please remember same radius. All right. Then 120 as center, I cut another arc. All right. Now, the point where the two arcs join, the intersecting point, is connected to the point at 1. Alright, now this joining you have to be very careful. Please mark a point as the intersecting point. Alright, now this point you will join. Alright, this point you will join. Now this is the joining point. We have drawn the line. This is 90 degree. So we have drawn 90 degree because if we don't draw 90, we can't use Pythagoras theorem. Alright, so we have drawn 90. Done. Now, because I have already taken 1 centimeter as radius, I need not cut arc of 1 centimeter on this 90 degree line. It is already 1 centimeter because I have taken radius as 1 centimeter. So, arc is already cut. This is the point. Alright, now with this point, we will join this point to 0. Alright, so this is 1 centimeter, and by Pythagoras theorem, we got root 2 centimeter. So till here, we have already done, and I have repeated the steps again. For root 3, you have to do till root 2 again. Alright, now comes the actual twist. Now for root 3, I said it is an extension of root 2. How is it the extension? Now we have taken this base as, now this is the line. Alright, this is the line PQ. Alright, now in previous sum also, let me mark this as P and Q. Alright, now I have marked this as PQ. Alright, so we did till root 2. Now, how is this the extension? PQ is the line which we have taken as the base. Now the base changes. Alright, now the base is this point O, and I can mark this as M. Alright, now this has shifted to this tilted position. Now what you will do is, in your exam, you change the position of your notebook. Bring this to the base and make it as the base, because you have to draw 90 degree from here now. So keeping it like this, base as PQ only, it is a little difficult to draw. In the exam, you just shift your notebook a little bit down so that OM, the 0 point and M. Okay, let me mark this as N. Alright, now this NM should be the base now. So just shift the notebook. Now taking this NM as base, I need to draw 90 degree. Alright, now I will take the same radius 1. Alright, taking radius 1, I draw a semicircle. Alright, now this is what, taking this as center, I mark this O. Taking this as center, I have drawn a semicircle. Alright, now this semicircle is to draw 90 degree. So taking this O, this N, point N, as the first center, I draw an arc. Now this is the 60 degree arc. The first arc is 60 degree. From this 60 degree arc, now your compass point, center point should be on this 60 degree. Taking 60 degree as the center, now I cut another arc. So 60 plus 60, 120. So the second arc is 120 degree. This is 60 first arc, 122nd arc. And as I have already told you, 90 lies just at the midpoint of 60 and 120. Alright? So now what is the next step? Absolutely right. Taking 60 as center, I cut an arc. And then which is the next step, children? Very good. Taking 120 as center, I cut another arc. Now the intersection point of these two arcs is joined to the center of the baseline. How is that? This is the center. This green line is the connection center from the intersecting point to the point on the line. This is 90 degree. Because if we don't draw 90, we cannot use Pythagoras theorem. Now we have drawn 90 degree. That means now we have come to a point where construction of angle is done. Now we want, root 3, as I have given you a rough work in root 2, I want to use a rough work in root 3 also. Alright, now this is point O. Alright, this is point N. And this is point, suppose, R. I take this as R. Now, this OR has to be 1. Now, this point is already root 2, already marked root 2. ON is already root 2. Now, if I use Pythagoras theorem, root 2 square plus 1 square is NR square. Now, what is root 2 square? 2 plus 1 square 1, that is NR square. Now, 3 is equal to NR square. NR is equal to root 3. Okay, now to get this root 3, one thing we have to do. What is that one thing? Alright, now we have taken from O. Now, I have taken 1 centimeter radius. Alright, now here I did not take 1 centimeter radius. So, one arc I have shown you as 1 centimeter radius. Alright, so you need not cut an arc. Now, this arc I have not taken 1 centimeter radius. I want OR as 1. OR is not 1. Now, where is the point of R? I need to cut 1 centimeter. Why? Because I have not taken the radius as 1 centimeter. Alright. Now, 1 centimeter cut. Now, what is this? This point is R. Alright. This point is R. I have to join R to N. Alright. Now, let me join. I have joined. Now, this is root 2. This is 1. This is root 3 centimeter. Is it clear, children? This is what is root 3. Alright. Now, it is not over yet. We haven't located root 3 on number line. We have marked root 3 as only as construction using Pythagoras theorem. Still, we have to mark it on the number line. How do we mark it? Now, the radius changes. The radius changes and now your radius is NR. The radius is NR. Taking radius as NR, I cut an arc. Now, this is the arc. Taking radius as NR, I cut an arc. This was root 2. Now, this is root 3 on the number line because value of root 3 value of root 3 is 1.732 and so on. Alright, so 1.7, here it is located. Now, definitely you will have doubt because you haven't measured it. You have just done by construction. What is the proof that the root 3 point here is 1.7? Please take 0 and measure till here, where the arc has cut the line. Measure, you will definitely get 1.7. Please round off to 1.7 because after 7 it is 3. So 1.7. You will definitely get the arc cutting the line, the baseline at 1.7. Alright, so this is the proof. Now root 3 you can't know, isn't it? You have written root 3 here and you can't know from this root 3 irrational number that this point from 0 to root 3 is correct. After converting to decimals, we got it as 1.7. Alright, now this from 0 to till this point should be 1.7. This is the proof that your construction is correct. Everything you have constructed is absolutely correct. Alright, but please be careful while changing the base for root 3 from this original PQ to NM. You can, here I can't shift my board, but you can easily shift your notebook so that you will have accurate 90-degree construction. Alright, so this is how we construct root 3, locate root 3 on the number line. So for root 3, there is no other shortcut. You have to do root 2 and extend it to root 3. And with that same principle, Pythagoras theorem. Alright, so this is how we locate root 3 on the number line. I hope it is very clear to you, isn't it?